Bonjour. So in this lesson we're going to have a look at algebraic division, where the numerator is a polynomial that's to a higher degree than the denominator, the bottom of the fraction. Before delving into all of the algebra though, I just wanted to have a look at what happens when we work with numbers. So 13 over 5, hopefully you recognise that we'd call that an improper fraction. It gets that name because the numerator, the top number 13, is greater than the denominator of 5. And when we've had a look at this lower down the school, when you will have initially been taught this, one of the ways that we can write it as a mixed number, we would do 13 divided by 5. So in this case, if 13 were to go in the bus stop, 5 doesn't go into 1, carry it over. 5 goes into 10 2 times, and I'd have a remainder of 3. So writing this as a mixed number, I would get 2 whole. That remainder of 3 would go there, and as the 5 is on the denominator, that would be 3/5. So that's what we do with that in terms of numbers. So now let's have a look at what happens when I've got an algebraic fraction where the numerator is bigger in terms of powers than the denominator. So here's my first example. In terms of algebra, what makes this a top-heavy fraction or an improper fraction is that the numerator is to the power of 2 and the denominator is just an x to the power of 1, if you were. So I have got that imbalance in terms of the top half is of a higher power, or it's weightier than the denominator. So we go about this the same way that we went about dividing polynomials in year 12. So if you prefer, you can consider it in this way. And I've just done a recap video of this in case you wanted a quick reminder, and just kind of go through this in a little bit more detail. So I'll just set it out very quick. So x squared plus 5x plus 8 would go inside the bus stop, and x minus 2 is what we're going to be dividing through by. So from the video, if you just had a quick recap, you know that we'll be asking ourselves, what do I need to multiply x by to give us an x squared? And the answer to that is x. So here I'll get x squared. Okay, so multiply that. Then we multiply the minus 2 by the x as well. So I'll get here minus 2x. And then we subtract those. So x squared, take away x, cancels out, which is exactly what we want. And with the subtraction here, 5x minus 2x is going to give me 7x. And I'm going to bring this 8 down. And then we're going to ask ourselves the question, okay, with this x now, what does x need to be multiplied by to give us 7x? Okay, so the answer to that would, as we've got the x already, is just going to be 7. And that is also a positive 7. So I'm going to put plus 7 here, and here I'll get 7x minus, so that was a 7x, and then the minus 2 times the 7, minus 14. And you'll see that the 7x's cancel, but here I've got 8 minus a minus 14, and so I'm going to be left with 22. So how you would finish off and finish writing the question then, you would say that when you divide x squared plus 5x plus 8 by x minus 2, you get x plus 7, okay, to start with, and then you have a remainder, and that remainder, similar to with our numbers, goes over the original denominator, which in this case was x minus 2. And that is that example finished. And this would be the final answer here. Okay, so here is another example. I wanted to have a look at this example because the difference in powers between the numerator and the denominator is different. So in my first example, I had something with the highest power of 2 over a linear function. The difference in those is just an x to the power of 1. And so as part of our answer, if you recall, I'll just swipe across. Part of our answer included an x. Now, when we look at the difference between the numerator and the denominator, that tells us a lot about what to expect in our answer. The difference here between the numerator and the denominator, so x to the power of 3 and the x to the power of 1 as denominator is an x squared. So in our answer, we're actually going to be looking for a quadratic function of some sort. Potentially, it could be ax squared plus bx plus c, or something of that form. And given that we're working with Year 13 maths, there's going to be some sort of remainder over that original denominator, I would guess. So again, just to recap, I'm going over this example because the power difference between the numerator and denominator is different to what it was in the previous question. I'm going to go through and do the dividing using the bus stop method, which you will hopefully be familiar with. Okay, so potentially it's the third time you've seen this now, so I am just going to go through it quite quick. We need to multiply x by x squared to get x cubed. Minus 3 times by x squared is minus 3x squared, and we are subtracting those. This is a minus here though, so do always watch out for that minus minus. X minus in minus 3x squared is 4x squared, and then I'm going to bring that 7 down, so I have there minus 7. Okay, just having a quick look at this question, I'm actually going to change it a little bit. So, where we've got that minus 7, the powers are not in descending order. So I'm actually going to put plus sort of 0x and then minus 7. Didn't quite pick up on that initially. So I'm actually going to bring down this 0x. So plus 0x, if you will. So next question, what do I need to multiply x by to give me 4x squared? I would need to multiply that by 4x. So I will have 4x squared here, and then when I multiply the minus 3 by the 4x, I'm going to get a minus 12x. And again, subtracting there. So I've got 4x squared minus 4x squared. I've got 0x minus a minus 12x, so that's 12x. And then I can bring the minus 7 down. So looking at what I need to get now, what do I need to multiply x by to give me 12? That's just a plus 12. So 12x minus 3 times by the 12 is minus 36. So no remainders there. Minus 7 minus a minus 36 is going to give me a positive 29. So in answer to the original question, what do you get when you divide x cubed plus x squared minus 7 by x minus 3? You are going to get a quadratic function, as I said. So x squared plus 4x plus 12. And then we're going to have that remainder of 29. And obviously the remainder always gets written over the original denominator, which in this case was x minus 3. Okay, so here is a question that I thought that you guys might like to try. So again, the difference between the numerator and the denominator is 2. However, the only difference here is that you're dividing by now a quadratic function, which is not necessarily something that you've seen before, but the process is exactly the same as it has been previously. So in setting up this question, inside your bus stop is going to be x to the power of 4 plus x cubed plus x minus 10. And we are going to be dividing that by x squared plus 2x minus 3. And that first question is still going to be the same. What do I need to multiply x squared by to give me that x to the power of 4? Well, that's going to be x squared. And learning from my mistake in the last one, I'm going to change this part here so that it says plus x or 0x squared. And then we've got the plus x and the minus 10. So have a go at that and see how you get on. Pause the video and then press play when you're ready to go through the answer. Okay, so you've hopefully got to this point, and you'll notice that in this case, because you're dividing by a quadratic function, you're going to have 3 terms whenever you're going through this algebraic division. So to finish off, your answer in terms of a, the coefficient of x squared, is just going to be 1. The coefficient of x is minus 1, so b is minus 1. C is 5, and then if we have a look at our remainder here, that's going to be minus 12x plus 5. That's all over the original denominator, as we say, which is x squared plus 2x minus 3. And that's the question done. If you like, you can write it out. So A is 1, B is -1, C is 5, D is -12, and E is 5. That's just if you definitely want to guarantee that you're going to get those marks in the exam for answering the question fully. So here is the last example for this video. And I really just wanted to show this to you just to demonstrate that this is the same question, but the added complexity there, the denominator has not been written out silly as just sort of one single function. It's factorised into two brackets. You can see though that the highest power we're going to get in the denominator there is x squared when we multiply the x by the x. So the power at the top and the denominator is the same, but if you consider something like 5 divided by 5, we're still going to get 1. So that's where this a comes into place. We've still got something that's whole, and then we're going to have a couple of little bits which is in parts there, which goes back to the previous bits we've done on partial fractions. So again, similar to the previous two examples, or three examples now, this is exactly the same process. You're just going to have to do that first bit of expanding the denominator there on that left-hand side. So if we just consider that quickly, x minus 1 times by x minus 2. So x times x is x squared. X times by minus 2 is minus 2x. Minus 1 times by x is minus x. And then minus 1 times by minus 2 is plus 2. So collating all of that together, x squared minus 3x plus 2. So I'm just going to rewrite that out now as 3x squared minus 3x minus 2 all over x squared minus 3x plus 2. So putting this into our bus stop method then, remember it's the top bit that's getting divided. So I've got 3x squared minus 3x minus 2. That's all being divided by that x squared minus 3x plus 2 there. So what do I need to multiply x by to give me 3x squared? That's just going to be the number 3. So 3x squared, multiplying that, minus 9x, and then the 2 times by the 3 is plus 6. So overall we're going to get minus 3 minus a minus 9, which leaves us with a positive 6x. Minus 2 take away 6, which is going to give us minus 8. So far, what we have is when you divide 3x squared minus 3x minus 2 by x squared minus 3x plus 2 is 3 whole plus this 6x minus 8, and all of that is over the original denominator, which is x squared minus 3x plus 2. However, if we consider that as 6x minus 8 over our original part, x minus 1 and x minus 2, you'll see that here in this section we've now got a partial fraction which, looking at how the question is laid out, they are expecting us to split. So we're going to need to deal with that, which we will do now. Okay, so just dealing with that partial fraction then, we know that the 6x minus 8 over the x minus 1, x minus 2 can be rewritten as a over x minus 1 plus b over x minus 2. So I'm just going to multiply through both sides by x minus 1 and x minus 2. So on the left-hand side, we're going to get 6x minus 8. This is a process that you're used to by now. We're going to have just that x minus 2 remaining in the numerator, and for b, we're going to have just that x minus 1 remaining in the numerator. So we choose values that will mean each of these brackets will independently be equivalent to 0. So let's say let x equal 2. So on the left-hand side, I'll get 12 take away 8 is equal to 0a plus, so just left with 1b. So 4 is equal to b. And on the next part, if I want to eliminate this bracket, I'm going to let x be equal to 1. So on the left-hand side, I'm going to get 6, take away 8, which is minus 2. And on the right-hand side, I know that the b is going to be multiplied by 0. That's the whole point of choosing 1. And then I'm going to have 1 minus 2, so minus a. So if minus 2 is equal to minus a, it follows that 2 is equal to a. And now we finally have our answer. So overall, when you divide that numerator by that denominator, you are going to get 3 whole plus, so 2 over, and a was over the x minus 1. It's always important to make sure that you do put the numbers back in the correct place with the correct denominator. And b was a positive 4, so I can write plus there, and that was over x minus 2. So that's the longest style question that you could possibly be faced with, and they could add the extra complication of asking you to potentially integrate that at some point. But to start with, we'll just focus on the dividing. Thank you.